Hey, what's going on, guys? It's Mr. Sanchez here, coming at you guys a pre-calculus lesson. Today we'll be doing section 2.2, the graph of a function. Our learning targets are to identify the graph of a function and obtain information from or about the graph of a function. This breaks down into two different types of problems. So there's three examples overall, multiple examples in each type. But let's just start with the simple one. Which of the graphs are the graphs of functions? So for these first three examples, it's very easy to tell what's a function. We're going to be doing what's called the vertical line test. So let's look at a problem A, right? We have this function here, and we want to determine it's a function. How do we determine if something's a function? Just our goal is just to draw a vertical line, right? And then let me see. And then what we can do with this vertical line is if you pass it along the whole graph, you'll notice that this only passes across the line, not the line, I'm sorry, the parabola once on each point. So because it passes, so because it never passes through this red line twice, we know that this is a function because it passes the vertical line test. Okay, and so yeah, all we're gonna do is say yes is a function for the first one. Okay, so for this first one, y equals x squared, that is a function. Let's go over to the next one, y equals x cubed. Okay, so we're gonna do again the vertical line test, and that's gonna help us determine whether or not we have a function or not. And if you look here, we pass through a vertical line. No matter where you pass through this graph, no point ever repeats itself. These arrows mean that the graph is gonna keep going in the direction, still going steadily up and increasing over time. Um, yeah, so this also passes the vertical line test, so it is a function. Okay, so we got that much going on. And then for the last test, for the last one, we're gonna go ahead and determine if this last one is a function. So if you go over here and we cross over here, you're gonna notice that we have one input, +1, giving us two outputs, 1 and -1. So right here, because it does not pass the vertical line test, you see it fails because it crosses. We say this fails the vertical line test because it crosses here and here. Fails vertical line, therefore not a function. Not a function. All right, and that's how you're very easily able to determine whether or not something is a function, whether it passes the vertical line test. And if it ever fails it, boom, automatic. If it crosses 2 points, automatically not a function. Don't worry about it. Okay. And that's the first type of problem that we're going to be facing in this section, which is why we call this example 1. Example 2 is a little bit more complicated, and you're going to have to write all of this stuff down. So you might want to pause the video and take a moment to digest all of this. So example 2 has to do with this graph right here. This is the graph of 4 sine x, but cosine x, but let's not get into the details of that. Actually, no, yeah, it is 4 sine of x. I don't know. Off the top of my head, it's definitely a sine or a cosine function. But let's look at this. All right. We're gonna be gathering information from this graph. Okay, guys. So how do we gather information from this graph? Well, we're gonna go start off by simply answering questions. What is f of 0 is our first question. F of 0, well, let's find out. F of 0 should equal to a number. So what's here? F of 0, so you see this, our x value, our y value is 4. So f of 0 is 4. And it's gonna ask us, what is f of 3 pi over 2? All right, so you don't need to know what 3 pi over 2 means. That's radians. We'll cover that, I believe, in the next semester. But if you go to 3 pi over 2, this is our x value right here at 3 pi over 2. Our y value is 0 here. So at 3, f of 3 pi over 2 is going to be equal to 0. And lastly, it says, what is f of 3 pi? Well, where is 3 pi? If you look at our graph here, 3 pi is right here. This is our f of 3 pi. Is going to be this part right here, the -4. So we're going to write f of 3 pi is equal to -4. And those are the values. Okay. Next up, the question is asking us, what is the domain and range of our function? So we've seen domain and range before, but in this case, for question B, what is the domain? And you see here how in this specific graph, we start and we have an endpoint, right? We have a place where we start or where we end. So the domain is going to be which x value we start from the left, where do we start, and where do we end? You guys are going to notice that we're going to start at 0, and then we're going to go from 0 all the way to 4 pi. So our domain is x such that it's going to be in 0 and be less than or greater than or between 0 and 4 pi. If you want that in interval notation, it's a little bit more complicated. You're going to go, actually, no, not that complicated. Interval notation, you're going to include 0 and you're going to include 4 pi because each of those give us an output. So you're going to include them like that. That's also our domain. Our range, however, is a little bit different. And some of us struggle with range. So our range is just trying to find out what is our highest y value and what is our lowest y value, right? So you'll notice that our range, and we'll write that in red, our range, and our range has to do with our f of x or our y, right? So we're gonna say y. Our y we start at -4, that's the lowest we can go, and the highest we can go is +4. So we're gonna say y such that y is between -4 and 4. Right, and if you want to write that in interval notation, that's gonna be a bracket of -4 and 4, because we include all the numbers in between. Right, there's a value here, here. All these values are included, so that's where our range is. Next up, it just says list the intercepts. So the intercepts is kind of the easiest part of this section. All we got to do is find our x-intercepts and our y-intercepts. Let's start with the y-intercept, right? Our y-intercept is right here. That's going to be 0, 4. And you're going to list them as points. Yeah, 0, 4. That's our y-intercept. Let's go ahead and list all our x-intercepts. Our x-intercepts are going to be these points right here. All right, and they're already nicely labeled for us, so all we got to do is write those down. Okay, so our first x-intercept is pi/2, 0. Our second x-intercept is 3 pi/2, 0. 5 pi/2, 0. And the last one, 7 pi/2, 0. Those are all our intercepts. And then we have a question that says, how many times does the line y = 2 intersect the graph for E? Right, so y = 2. All we're gonna do is basically like a little horizontal line test. It's not technically a horizontal line test, but if we draw this line right here, at y = 2, what it's asking is how many times does the graph cross there? You'll notice it crosses it 1, 2, 3, 4 times. So that's what you write. 4 times. All right. For what values of x does f of x equals -4? So for question F right here, first let me move this over here so we have some space. But right now we're gonna work on question F. Oops, what did I do? Let me see. Let me close that up. Yeah, so right now it's asking us for what values of x does f of x equals -4? So there's two values. There's this one right here and this one right here, right? So it's gonna be the x values in this area, right? So the answer is gonna be for x equals pi and x equals 3 pi, okay? Because these are the 2 points where our y is equal to -4, okay? And then for the last one, for the last section, it asks us for what points is f of x greater than 0? For what values of x, right? So this one's a little bit trickier, but basically wants us to know which areas, at what points are we greater than 0? So you notice we're going to be greater from 0 from here to here, from here to here, And from here, you see these highlighted areas? Those are the points where we're greater than 0. And we're gonna go ahead and write that in interval notation, okay? So let's see, if you'll notice this, we're going to include 0, right? Because at 0, we're good. We're good, we're good, we're good, we're good, we're good. And then at pi over 2, we're gonna be equal to 0. So because at pi over 2, we are equal to 0, and we want to be strictly greater than, we're not going to include pi over 2 as our answer. Okay, as part of our answer. All right. And then we're going to union it. And then the next time we pick up, it's at 3 pi over 2, right? 3 pi over 2, we're going to go bigger, 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 greater than 0, greater than 0, greater than 0, greater than 0. Boom. All right. We're not going to include 3 pi over 2 because at 3 pi over 2, it's exactly 0. But and then you're going to notice right here at 5 pi over 2, it's where it hits 0 again. And because it hits 0, we're not going to include that as part of our answer. And then we're going to union that with this last part. At 7 pi over 2, we're not going to include 7 pi over 2 because that's where it's equal to 0. But everything afterwards, you're going to be greater than 0. And you're going to notice we stop at 4 pi. And we include 4 pi because that is bigger than 0, right? And so that's it. That's what those are the values of x where it's greater than or equal to 0. Okay. This part is a little bit tricky, so if you need help, make sure to ask me in class or send me a message on Schoology, and we'll be able to go over all of this together. All right, we have one more set of problems that we got to go over. So this is looking at the graph to get information. Now we're going to look at the function to get information from the graph. Okay, so I'm going to go ahead and go over to the next slide. So we have this current function right here. F of x is equal to x plus 1 over x plus 2. Find the domain of x. Since we have a denominator, we can't let the denominator equal to 0. So you're going to do x plus 2 cannot equal 0. So x cannot equal 2. And that's our answer. That's our domain of f. But we like writing it like this: negative infinity to 2 union 2 to infinity. That is what our domain is. Okay? Once again, why? Because we're not including 2. Actually, it should be -2. My bad, because you're going to do -2 to both sides. -2, -2. Next up, it says is the point 1 comma negative 1 comma 1/2 on the graph of f. So what this means is you're going to plug in 1 for our x. So this is our x and this is our y. So our f of x. So we're saying 1/2 is going to equal to 1 plus 1 over 1 plus 2. I put parentheses around our ones because that's where our x would normally be. So we're replacing our x with that number, right? And if we evaluate this, right, you're gonna get 1/2 is equal to 1 plus 1 is 2, and then 1 plus 2 is 3. This is not an equal statement, so no, the point is not in the function. The point is not on the graph. Okay, so that's not included as part of our answer. Okay. The next question, if f equals 2, what is f of x? What point is on the graph of f? All right, so basically right here, all we're doing is plugging in, we're going to do f of 2. What is f of 2 equal to? That's what we're finding out. So let's go ahead, plug that into our equation. Where is x? Right, we're going to have x's here and then x here, right? Because our x is equal to 2, we're going to plug in 2 here. And you're going to get 2 plus 1, which is 3, over 2. 2 plus 2, which is 4. So our point is going to be 2 comma 3 over 4, and f of 2 is equal to 3 over 4. Okay, this is our value, and this is the point that's on the graph. Okay. Similarly, so that's when x equals to a number. If you ever get f of x is equal to a number, you're going to be doing the opposite. You're going to be letting f of x part equal to 2. So you're going to write 2 is equal to our f of x, right? So our f of x is x plus 1 over x plus 2. So now you're going to write x plus 1 over x plus 2. And now we got to solve for x. And the trick is you're going to write 2 over 1. Right, you're going to make this a fraction, and you're just going to cross multiply. And this is going to give you 2 times x plus 1 is equal to 1 times x plus 1. Okay, that's the easiest way to explain it. You're gonna do some distributive property, 2 times 2. So you're gonna get 2x plus 2 equal to x plus 1 because anything times 1 is 1. And then you solve for x. Right, you're gonna do minus x, and then minus 2 right here. This is gonna go away. 2 minus x is gonna be x. It goes away. 1 minus 2 is negative 1. All right, so that's x equals negative 1. So our value is gonna be negative 1, comma 2. This is the point that's on F. Okay. And all right, the next part is what are the x-intercepts of the graph, if any? So for x-intercepts, remember you just let x equals 0. Oh no, you let y equals 0. So let y, in this case, f of x, right, equal to 0. So you're going to get 0 is equal to x plus 1 over x plus 2. You can do the cross multiply trick, but because this is a fraction, we're basically just gonna let the numerator be equal to 0, okay? Because it's a fraction. If you have something else, then you'd have to solve it. But because it's, well, you know what? We'll just do it this way. This times this times that. So you're gonna get 0 times x plus 2 equal to 1 times x plus 1. You're gonna notice anything times 0 is 0, so this goes away, and you're gonna get 0 is equal to x plus 1, which this is going to tell us that x is equal to negative 1. Right, so our x-intercept is gonna be negative 1, comma 0. Okay, and that's basically it. That's all the information we needed to graph. And then this information that we can easily get from our function using all our algebraic tools, okay? If you have any questions, feel free to ask me in class. This is somewhat of a longer video and it's gonna take you a while to take all the notes. So I understand that this takes a long time. But ask questions if you need to in class. All right, guys. Have a great day. I'll see you all in class. Bye-bye.